Your videographer from Two Hats Publishing. I welcome you to the College of Complexes, recorded live in downtown Lakewood area, nestled gently against White Rock Lake. Downtown Lakewood is home to the restaurants with family values and family history to match. Visit the Mecca Restaurant at the corner of Skillman Avenue and Live Oak and tell them you want your reservation to the next College of Complexes class.
Well, welcome to the College of Complexes. This is our 192nd meeting that we've had since January of 2009. Can you hear me all right? Just checking. Yeah, well, good. We put a speaker on every week, a different subject. We require our speakers to take a position on an issue, express a point of view. If anybody interrupts the speaker, we remind the interrupter that we only listen to one fool at a time. After that, we have questions and answers, not speeches. Then we have remarks, rebuttals. Everybody in the audience that wants to gets 5 minutes at the podium here to respond to what the speaker said, for or against. Then our speaker gets to comment on the comment and close the meeting. That's what we do every week. Anyway, before we put our speaker on, though, are there any announcements? Now's the time for announcements. Do you have any announcements you want to make? Anybody have any announcements? I can't believe this. Usually there's announcements. Susie's not here. All right. No announcement from Susie. Got any announcements? All right. No announcements. Okay. Well, next week we have, for announcements, I might as well go through this. I left in front of you, you should have the itinerary of speakers for the next month. Next week is the last great reform of the Federal Reserve Bank, commissioned by the Dallas College of Complexes. Lloyd Chappelle is going to talk about the bank reform, what needs to be done, etc. He'll be here. On August 24th, we have UFOs and abductions, fact versus fiction. And Jim O'Connell is going to talk about that. It ought to be good. August 31st, we have Labor Day, past, present, and future. Gene Lance, he's president of Labor Dallas. He's going to talk about that. He'll be here. On September 7th, we have 5 famous free thinkers. Stephen Butler, historian and author, he's going to talk about the 5 people here at that time. September 21st, we have Nuts and Flakes, the creation of the American breakfast food industry. Paul Benson is going to talk about that. On October 5th, which is not on there, Michelle Valentino is going to talk about Beyond Lore and Legislation, a real-life perspective on unattended pregnancy. That ought to be good. Pat O'Connell, who's sitting right here, is going to be our speaker on August 24th on UFO and alien abductions, fact versus fiction. It ought to be quite interesting, and I'm glad that she corrected me that I gave her brother's name here. He's not going to be here, so thank you. Anyway, that's what we have coming up. I don't want to bore you with all this, but you've got it in front of you. So as long as there's no more announcements, our speaker tonight is John Walker. He's a Ph.D., a neuroscience researcher for 30 years, teacher at various branches of University of Texas. He's a specialist at explaining the subject in clear language, and author just completed a book on the same title as this presentation, which is Logic and the Brain, a Rethink. He will discuss how the past 2 decades have been a huge advance in bioscience, accompanied by equally huge speculation on how we think and how you might expect a lot of controversy. Dr. Walker will cover a series of ideas on the subject, all controversial, and all on which he has developed clear and rather strongly held opinions. His presentation on controversial developments in neuroscience will include organization of the brain, the nature of, and I can't read my own printing here, organization of the brain, the nature and function of memory, consciousness of self and self, decision making, and perception. So without further ado, please give a very, very warm welcome to our speaker tonight, John Wallace. Walker, excuse me. John Walker. It's a problem what happens when you can't read.
Thank you very much. The online billboard, and you know, do something if you can't hear me or understand me. I might be able to shout louder than this can reach you, or at least more clearly. But the online billboard announcing this presentation mentions that I plan to discuss controversial opinions about how our brains work. To many people, that word controversial doesn't sound very scientific. Haven't the brain scientists, like other scientists, conducted carefully designed experiments, reaching carefully stated conclusions that can then be replicated by other careful scientists? Above all, haven't they avoided any unproved speculation about their subject? If so, then why the controversy? Let me see if this works. Yeah. Well, the answer is that they used to try to be objective, or at least they used to pretend to try. Can you hear me? Is it clear? Am I clear? What? Closer? Yeah. Can you hear me now? Okay. Here we go. The answer is they used to try to be objective a good half-century ago, but that didn't leave them with much to say, at least compared to scientists in other fields. The problem was that they couldn't look into a working brain to see what was happening. There were no X-ray machines or other devices that could show our brains thinking. The closest they could get to it before 1990, short of actually inserting needles into brains to pick up electrical activity, as some scientists found reason to do, say in the case of operations on severely epileptic patients, the closest they could get was what the old EEG or electroencephalograph could give them. As you know, EEG involved pasting electrodes all over a subject's scalp to detect the magnetic fields produced by the brain's electrical activity. Problem was the brain produces so much electrical activity in such tiny voltages, 10,000 times smaller than the electrical field generated by an AA battery, is a common comparison, that the result of an EEG scan represented on an oscilloscope resembled a close-up snapshot of a haystack, or the artistic production of a 2-year-old whose mommy hasn't given him a new sheet of paper for a month. No wonder 20th century neuroscientists decided that most of it was static and not the signals they were looking for. By contrast, the most admired scientists of the 20th century, the astrophysicists, had their viewing instruments since Galileo. They could look at a planet through their telescopes and see what they were looking for, a planet. Looking at a working brain, of course, even through a microscope with a portion of the skull and the meninges removed, isn't a lot more informative than looking at a dead brain. Besides, since 1905, astrophysicists had a formula that seemed to explain a lot of what was going on out there. Einstein's E equals mc squared. Neuroscientists also had some models or explanations of what's going on in here. Mostly developments of theories first presented by William James in his 1890 publication, Principles of Psychology. But although James's book is a classic work of genius, its explanations, as I'll mention again later, fell far short of the final statement that Einstein's equations seem to make, still valid even with the onset of quantum physics. To complicate the neuroscientist position, their field was dominated by behaviorist philosophy for the first half of the 20th century. Behaviorist psychologists, followers of Ivan Pavlov of salivating dog fame, took the position that since they can't see what's going on inside people's heads, they can't really talk much about it because anything they say would be conjecture. They felt they could only judge what's going on by its visible results, that is, the behavior of the person or animal they were observing. Pavlov was a physiologist, not a psychologist, but his methods had a profound effect on the psychology of the next half-century. Pavlov could actually see the dog salivate every time the bell rang, which very likely meant a connection in the brain between the two events. Psychologists longed to imitate the clarity and certainty of Pavlov's experiments, but this approach turned out to be very limiting. Reflex reactions just couldn't get very far in explaining most of our brain activity. Certainly not how the part of the brain that does our thinking actually does it. I should point out that behaviorism didn't shut down discovery entirely. There was neuroanatomy, which continued because it could be conducted on dead brains. Equally important, the behaviorist approach included study of changes in human behavior resulting from brain injuries. Neuroscientists reasoned that if a change in behavior followed injury to a particular part of the brain, that was likely to have some share in controlling that area of behavior. Both of the famous 19th century discoveries of the language processing areas in the lower left side of the brain by Paul Broca in the 1860s and by Carl Wernicke about a decade later derived from injuries in those areas of their subjects' brains. This was the first indication that we had that the areas of the brain specialized. Before that, they thought the whole brain did all the thinking, and that was always necessary. The most famous of the brain injury patients is probably Phineas Gage. In 1848, an explosion drove a steel rod through his frontal lobe, destroying some of it, but leaving him miraculously alive with the rest of his brain intact. However, his change in behavior was profound. There it is. The change in behavior was profound. It was said of him that before the accident he was a reliable person of exemplary character, but afterwards he was a foul-mouthed and ill-mannered liar given to extravagant schemes that were never followed through. The researchers concluded that the damaged part of the brain regulates social behavior. I want to mention another famous brain damage case because it involves the hippocampus, a neural organ that's important for memory, which I want to talk about presently. Henry Moliason was severely epileptic. All the usual remedies had been tried, but he suffered more and stronger seizures every day, and it was clear that they were killing him. Finally, his doctors agreed to resort to brain surgery, even though not much was known in 1953 about which areas to operate on. The surgery succeeded in relieving the epileptic attacks, but the surgeon had cut into Moliason's hippocampus. After that, Moliason couldn't form new memories. He could still function in some ways, but only if he'd learned how 10 years before the operation. A few minutes after he met you, he would have forgotten he'd ever seen you before. There was a film out few years ago about somebody who had that problem. Do you remember the name of it? I couldn't find it. If you remember, tell me. It's somebody who can function in the moment, but minutes later he has forgotten all about it. The breakthroughs of this sort were fortunately rare, and the dominant doctrine among neuroscientists for the first half of the 20th century was behaviorist. For that reason, conjecture was severely criticized and therefore subdued. Brain scientists were mostly good scientists, that is, compliant, well-trained workers who got with the prescribed program and submitted to the rules and daydreamed that they had chosen astrophysics instead. For that reason, it took a non-neuroscientist to change things. This is Noam Chomsky. He was a young linguist at MIT, and since 1955 he had been arguing that the neuroscientist behaviorist Puritanism had resulted only in trivial insights. Here's a typical comment from him. The reader who undertakes the useful exercise of searching the literature, that is the behaviorist literature, will discover, I believe, not only that there is little significant scientific knowledge in this domain, but further that the behavioral sciences have commonly insisted upon certain arbitrary methodological restrictions that make it virtually impossible for scientific knowledge of a non-trivial character to be obtained. In other words, they ought to speculate a little more, because if they don't have anything to say. He argued that overcoming their fear of being wrong could result in some good testable conjecture, otherwise known as hypothesis, and so nurture discoveries of the brain. Other linguists pointed out that their own field had the strongest claim to provide these conjectures, because human language is, after all, a behavior, which, unlike salivating at the thought of food, provides a complex and deep-reaching view into the most sophisticated human thinking. By 1960, the movement was well underway, and by 1970, the neuroscientists had to face the fact that as many linguists were producing studies about the brain as they were doing themselves. Ultimately, a few young neuroscientists joined in, and by the time they were established, they were doing a lot of speculating. And so speculation and conjecture returned to neuroscience, along with continuing controversy about whether it belongs there. But the primary cause for their return to prominence wasn't just that they overcame their fear of speculation. It was the advent of some wonderful new tools and a flood of new information from outside their mainstream, which has resulted in as rapid a set of changes as any science has ever recently experienced, including biology after Darwin in 1858, or physics after the quantum physicists began their work around 1910. One dramatic change resulted from the refinement of the electroencephalogram. You recall that early versions of this instrument picked up a chaos of what was thought to be noise and static. But slowly, as the ability of the instrument to distinguish between different brain waves improved, researchers started picking out signals from the noise. In fact, they realized that all of the noise may be signals. These signals included reliable reactions to inputs, and by the way, since the most convenient input was often linguistic, many of the younger linguists started using EEG in their approach, in their research. Now it's hard to distinguish them from neuroscientists. In a bit I'll give you some interesting examples of one of these types of signals called the -400. The biggest breakthrough, however, was fMRI, which must compete with the Hubble telescope for the title of, say, invention most responsible for enabling us to see further than we ever have before. You recall that the biggest problem faced by brain researchers was that they couldn't see the brain working while it works. MRI magnetic resonance imaging, as you may know, can provide shadow images of the insides of soft tissue as X-rays can do with bone. That means that it can show scientists the insides of brains in layers, but it can't show the brain working. Thinking, which is what the brain does, takes place in time. So an MRI snapshot is useless for showing that. Even the shadows of reality at the back of Plato's cave were moving shadows. Functional MRI, however, is to ordinary MRI as a video is to a snapshot. And like a video, it can show which parts of its subject are active. fMRI, that is, can show us on a monitor which parts of our brains are thinking at any given time, say to the response of a central input. Furthermore, it has been linked to a computer program that can translate its signals into 3D representations of brains on monitor screens. Scientists can watch these changes in recorded slow or stop motion. They occur very rapidly, sometimes within a few microseconds. And they can see when other parts of the brain join in or when some parts stop thinking and others start. This was a huge advance for neuroscience. That's why I like to date present-day neuroscience from 1990. It was the year when, for the first time, scientists could observe neural operations while they're actually operating. So, conclusions. As you might imagine, the new viewing instruments provided information that undermines some of the conjecture and speculation that had been going on. Some scientists found their pet theories under attack, and they defended themselves and their careers by pointing out flaws in the methodology of the new research. Naturally, they succeeded in finding some, particularly since the new research had itself led to new conjecture and speculation. Now that they have the means for studying their subject, this is the second reason, they had previously lacked, the pendulum is swinging back, and many scientists are calling for more cautious conjecturing. One of my favorite neuroscientists is a man named Vaisakhi, and he gives us a good warning that in spite of all of the advances we've made, we have to realize that we still have a long way to go. As one of my favorite neuroscientists said, he wrote the book on brainwaves, even the combined simultaneous application of all our new research methods falls short of the goal of explaining how neurons, that is brain cells, and neuronal assemblies make sense of the world, generate ideas and goals, and create appropriate responses in a changing environment. That is, brain scientists still can't see exactly how the brain works. Nevertheless, the scientists know they now have ways of watching some of the brains working while it works, and that's got them a long way ahead. Okay, now what I would like to do, I did that mainly just to give you a little bit of background, but in spite of the fact that you aren't supposed to ask questions, if there's anything I say that you consider important, so want to ask a question, I'll try to clarify it right away. Let me ask you a question. I'll ask you to bear with me on this. It may sound like a silly question, but a pretty smart guy in history named Socrates asked the same question, and he made something out of it, so I'll try to do the same thing. What I want to ask you is, how do you know that this table has another side? You haven't seen the other side. I watched you come in, at least some of you, and none of you pulled that table out to make sure it has another side. And yet you're absolutely certain that it does, aren't you? How do you know when you haven't seen it or touched it or sensed it in any other way? How do you even know that it's a table? Would you agree with me that the only source for this information is your memory? Yes? You are applying your memories not just of this table, but of all the tables you've ever seen, and in fact of all the objects you've ever seen. And that's why you didn't look at the table thinking, you know, what's wrong with it? It doesn't have another side. You understood that it did. Why? Because the only way is that you must have applied a template to this table from your memory. Would you agree with that? Does anybody disagree? Okay. Then would you agree that you add as much to everything you see as your senses do? Anything you see it's not as though you're looking at something real out there. It's as though you are creating something real by adding what your senses to what your senses give you, a template which, in short, interprets it. Yes? So you interpret everything you see in the act of seeing it. Okay. Let me do one more thing before I get into memory, because I'll mention this particular neuroscience several times. In 1985, I've been reading neuroscience. I know I don't look that old, but I've been reading neuroscience for a long time, about 30 years. I ran across an article in the Journal of Neuroscience. I was at University of Texas at Arlington at that time. It was by a man, a neuroscientist from Colombia, of all places. It sort of surprised me. I didn't think they had any neuroscientists in Colombia. I thought all they did down there was provide us drugs. Furthermore, he wasn't a neuroscientist. He had been working with single-celled creatures, amoebas and neurocoats, you know. But recently he had been supplying what he learned to research human cells, especially neural cells. And he was arguing in this essay that the neuroscience treatment of neurons was much too simple. He talked about phosphorus and calcium deposits, which I'd never heard of in neurons, and the ports in cell walls that allow these ions to come and go and so maintain a balance and build up a charge, which is how the neurons pass on their electrical charges. He was suggesting a continuity of operation between the way single-celled creatures work and our body cells, including neurons. I didn't know, for example, that all cells oscillate. You've heard of brain rhythms, right? You've heard of the electrical rhythms in the brain. Did you know that your muscles also continuously oscillate? And that the brain rhythms coincide with the muscular rhythms to lift something, to make your muscles work. Now here was a guy in 1985 from Colombia, telling the leading American neuroscientists that they'd better get back to work. It was too complicated for me. I mean, you know, I let other people work on it. But since then they've been at work, and now everybody knows these things. Later, this same author challenged the overall model in terms of which scientists view how we think. I'll get to that part of my first issue, as part of my first issue. But let me introduce the man in case you don't know him. Rodolfo, who is now head of neuroscience. I mean, they picked him up pretty quickly. Head of neuroscience of the medical school at New York University, where he's been for about 10 years now, or longer than that. More about him in a minute. For now, let's look at our first controversy, the overall structure of the brain. Another exciting reading I did once was a book that I encountered about 1980 by Carl Sagan, called The Dragons of Eden. I don't know if you've heard of that. But it turns out that he had picked up all of his ideas from Paul MacLean, who had developed the idea of the triune brain. It was very exciting stuff at the time because it was just so tidy. It was so neat, combining brain anatomy with evolution, with everyday psychological problems we all have and need to solve. He said that we don't have one brain, we have three, which we inherited from different eras of our long ago animal predecessors. First is our what we call the brainstem, which is our reptilian brain, developed from our lizard ancestors. It's the brainstem, what are called, we now call the brainstem and the cerebellum. It handles the basic operations of our bodies. Reptiles, he argued, don't really have any emotion. Emotion isn't just a matter of feeling, it's a matter of feelings that motivate you, feelings that make you do something. Reptiles, apparently, according to McLean, have to do without that because they don't have the brains that give emotions to us. The brain that does is called paleomammalian, also called the limbic system. Beneath our cortex, which is a big sheet, which is all wrinkled up and wrapped around something. It's wrinkled so that it can get inside our skull, because it's that big, to start with. The something that it's wrapped around is a bunch of nervous connections, but also a set of small organs which have specialty uses. Okay, those, he said, exist in order to supply emotion. He knew they did other things as well, but that's basically what they do. And then finally we have our neocortex itself, the thing that looks like a brain, which is the sheet, wrinkled up sheet that I told you about, which is called the neuromammalian. Only higher mammals have them, and it's most highly advanced, of course, in the human neocortex, and it enables thinking. Brains, he says, these three brains cooperate, but also have some conflicts. The main one is between the logical cortex and the emotional limbic system. I remember an incident that occurred to me at a party once where a very sincere and forceful young man explained to me that as an older man, I was older even then, this was years ago, as an older man, I allowed my masculine, the huge dead weight of my masculine logical cortex to suppress with its huge dead weight the feminine feelings of the tiny little organs that constitute our limbic system. I didn't know what to say. I told him I'd try to do better. And he went to find somebody else to convince. I was very relieved when I found out that he had got it all wrong. McLean himself didn't make much of the masculine and feminine roles that those parts of the brain play, but he took for granted the mainstream model of our basic thinking, which was current at the time, and it derived ultimately from William James. Its center is the processing of sensations. What our brains mainly do is take sensations in through the eyes and everywhere else. Our eyes were assumed to be like cameras which took in the world around us essentially as it is. We see reality as a camera does. These sensations, also the others, touch, smell, hearing, are perceived and understood by the cerebrum, the cerebral cortex, and routed through the limbic system where they pick up emotions as required, then sent to the muscles and other parts of the body in the form of instructions about what to do. They knew that it was more complicated than this, but the main outlines of this model were still in place. And it was accompanied by a theory of human nature that saw our brains as basically information gathering machines. I had my doubts even then. When people were described, they were described as very curious, very keen to gather information. Most of the people I knew weren't like that. I knew a few who were like that, but most people were content with the information they had and were willing to spend time gathering it only when they were forced to do so, because some aspect of their behavior wasn't working. I had that problem myself for a while. Anyway, McLean published the final version of his theory in a book called The Triune Brain in Evolution. The year was 1990, the same year or a year or two before the advent of fMRI. Sometimes some scientists expected to see sensations following the neural routes outlined in McLean's book. But when they first looked at fMRI, what they saw was nothing like that. It was a whole lot more garbled and complicated. There were loops going on. Most of the controlling, most of the emotional controlling was done from the cerebral cortex. Certainly the amygdala had something to do with fear and anger, but basically it didn't just process it right down to the muscles. It went round and round many times. The eyes went through the visual cortex, which is right back here, the back of your head, but then it went directly, before it went to the visual cortex, it went directly to the cerebral cortex. So it was thinking about it before it got the processed vision. And the vision that was sent wasn't simply a single camera image. It was all broken into different colors and lines and processed in different ways. And it was hugely complicated. I thought at the time, and I still think, I know what was happening. I told you I was eventually going to get controversial. I believe that what was going on was all of this application of templates, which we just illustrated, right? We are not just seeing things, not just taking vision. We are checking them against our templates. If a template doesn't work, if we have a contradiction, then another set has to be found. Also, this table isn't just a single template. Actually, it is mainly a table template because the single templates develop after a while. But to none of you in this room does this table look the same. It has a different shape depending on where you're sitting. It has a different color or colors depending on, how the light is reflecting from it. And you are all putting together your own table instantly. You're all putting together your own table by applying memories. Do you see why it takes so many cycles, so many circuits, and so on? I mean, that's what I think. A lot of leading neuroscience scientists don't think that. Edelman calls these cycles re-entry. And for him, it has to do with something totally different, which I won't tell you about because it's wrong anyway. But anyway, okay. The most popular replacement model, now that the three-brain system has been discredited, is that one. It's called the thalamocortical system. The thalamus, which was just one of the little organs in the limbic system, turns out to be exceedingly important. All it does is send signals, but it must be by far the most complex signal box in the universe, just as the brain is said to be the most complex object in the universe. It sends many signals, many versions of all these signals, mainly to the cortex, receives them back, sends them to other parts of the brain, finally sends them down the brainstem. It sits right on top of the brainstem. It's a very important part of the cortex. And so it is now combined with the cortex and called the thalamocortical system. Then these other organs in the limbic system, and notice I still call it the limbic system. These other things do specialist jobs, but they do a lot of different specialist jobs. The hippocampus, which I mentioned, processes memory. It turns our memories into long-term memory, and it takes 10 years to do it until they're really embedded in long-term memory, which occur at the different parts of the brain, not in the hippocampus itself, but in the different parts of the brain. In fact, what happens, I'll just tell you, I hadn't intended to, but when you see something, one tiny aspect of what you see is channeled through a series of neurons, which are what are known as pre-potentiated, so that they can only take that one thing. And that's how the template works. It's more of a filter than a template. And somehow the brain puts together thousands of these things in an instant the minute you look at something. It's something like cookies in a computer, though I don't want to make the big mistake of saying the brain works like a computer. But the brain is prepared to see a table because you've seen so many tables that it has its own thing, and then it adds all the colors and so on within, what, half a second, so that you see it right away. Anyway. Anyhow, the thalamocortical model handles all of these loops. I mean, explains all these loops much, much better. And this brings us to some more information I want to give you on memory. Now that you've all agreed with me, I saw you all nodding your heads when I asked, do you agree that we apply templates and that that's what memory is for? That is, the primary function of memory is not to recall the past, it is to recognize the present. Okay? Not that we don't recall the past with it, but it doesn't seem to be the main thing we do with it, because every time we look around, we're using our memories. Okay. But, oh, okay, yeah, it looks good enough without the sheet, doesn't it? Thank you. See, I carefully arranged my PowerPoint so that I didn't have to look at it. That's what I get. Okay. Let's see. I'm going to skip over some of this. Professor Yinas goes even further than saying that what the memory does is give us an interpretation of what we see. He points out that the main difference between the animal kingdom in nature and the vegetable kingdom is that animals, even the simplest ones, have nervous systems of a sort, whereas vegetables, including trees and funguses, don't. And that, he says, is because animals move around and trees and bushes don't move around once the wind blows them. The pervasive purpose of nervous systems, whether we're referring to humans or dogs or amoebas, is to enable their hearers to move to where they can satisfy their needs and avoid danger. Or to put it another way, to enable them to predict the future. Applying that to our speculations about memory, we can postulate that that's what memory is for, to enable us to predict the future. Now, my first reaction to Yinas' theory was probably the same as yours. Don't be silly, I said to myself. We can't predict the future. And then I realized that we do it anyway, or try to. We do it automatically, and we do it unconsciously. Let's start small, as the brain researchers do. I mentioned that some linguists have started using the new research devices like fMRI and improved EEG as though they're real neuroscientists. Let's look at the experiments of Marta Curtis of UC San Diego and Bernadette Schmidt of University of Maastricht in the Netherlands. In these experiments, they're using an EEG program called expectation-related potential. It detects a brainwave signal called, as I mentioned, -400, meaning it occurs less than half a second, that is 400 microseconds after an input. This signal has been reliably shown to represent a response to only one kind of reaction: surprise. The subjects are shown this sentence. She was stung by a bee. Is there anything surprising in that? No. So you don't get any 400 -400 reaction. These were actual experiments conducted on subjects. Okay? Now try this one. She was stung by a hive. Sure enough, nearly half a second after the subjects read that, they get a little jump. They are surprised. Now what does that mean? Think about what that means. It means they must have thought they knew what that sentence was going to say before it was finished. Otherwise, how could they be surprised, right? And what they knew it was going to say was something that they already knew. That, you know, I mean, I suppose hives can sting people, but only if you're referring to a whole hive full of bees. Apparently, what happens is that at the beginning of every sentence that we hear, we formulate a theory about what it's going to say. And then we modify the theory as we go. But you know, only if we're surprised. Now look at this. This gave them a really big jump in the -400. You know, it almost doesn't make any sense. So it gave them a jump, and also a jump in the confusion lines that they were also monitoring. Obviously, if the brain is surprised by some of these messages, it must have been expecting something else. And if it expected something else, it was trying to predict the future, unconsciously. The fact that this pattern of the brain responding to a message in terms of what it expects applies to forms of communication larger than single sentences, what our authors refer to as discourses, is illustrated by the following example. I'm reading from what the researchers said. As single sentences, both the aardvark went quickly into its burrow and the aardvark went slowly into its burrow are equally plausible, and the words within them should elicit about the same normal sentence signals as they did. These were the predictions of the scientists. However, put into a larger discourse context, such as it was a quiet summer day, the aardvark was surprised by the sudden appearance of the tiger and went, the two adverbs quickly and slowly are no longer equally expected. And instantly, people expect, once the tiger is seen, only a couple of words before, they expect the quickly. And that the aardvark went slowly into the burrow causes a spike. Isn't that interesting? We build models of not only everything we read, every movie we see, we build models of every single thing that happens to us. And we understand them in terms of these models. Cheers. Yes. Apparently, yeah. Yes, and that was exactly what they got in that case. They got the surprise if it still went slowly into its burrow. And as the authors go on to say, data from several studies show that important context for modulating the signal is not just a related word earlier in the sentence or many words of the sentence, but also the larger context of the discourse of which a sentence may be but a part. Now, if you need further proof, let me just ask you a few questions. Suppose you were to get up and go into the next room. You know, the waiter isn't fast enough. You want to order something. You want to see if one of your friends is sitting in there or whatever. And as you step into the next room, you see a big fiery gulf with bubbles dancing around instead of the room. Now let me just ask you one question. Would you be surprised? And I take it the answer is yes. And therefore, you had a theory in your mind of what you were going to see when you went into that room, weren't you? Otherwise, you couldn't have been surprised. Is that true? Yes. Okay. So, now this is, most of you are mostly agreeable with what I'm saying. So, let me warn you ahead of time, this is going to throw you. Does anybody recognize a pattern in this sort of expectation? I'll help you. Oh no, I don't want that anymore. Yeah. Does anyone recognize this pattern? A template is applied to a particular observation or thing to reach a conclusion. What? Who said yes? What's the pattern? Can you name the pattern? Maybe not. Yeah. Does anybody know the technical name for that? Okay, it is syllogistic. It is a syllogism. You have a major premise, the template, a minor premise, the particular observation, and a conclusion, right? But you haven't heard of syllogisms, or if you have, you just immediately rejected that knowledge because nobody studies logic anymore. And yet it is absolutely basic and central to this new model of how we think, which I'm suggesting. You see that? We understand by applying templates, and that means we think logically. Now, most of you think that logic has something to do with emotion or with feeling. Oh no, it has something to do with being unemotional or unfeeling. But I would claim that we also feel logically. You know, we go out into the road, we hear some squealing brakes, we jump back. Okay, major premise. When I hear squealing brakes, I jump back. Those are squealing brakes. Conclusion, I jump back. You know, we're thinking that all unconsciously, but it's nevertheless syllogistic. Do you follow me? Okay, here's another one. Here's a template, a set of assumptions we have. Any object of a size to fit into a room that has a flat horizontal surface, obviously for putting things on, and just sits there without moving about so high off the ground with legs to keep it at that height, offering convenient relief from any weight we're holding, is a table. You see, those are a bunch of templates which we apply to it, right? Okay. That particular application and observation we make, that object that you just glanced at when you came in and then put your stuff on it, has those characteristics. Conclusion, that object is a table. If you didn't go through that procedure, you would not be able to recognize the table, not know to put your stuff on it, right? Okay? You know, I'm not talking about anything fuzzy or you know, symbolic or anything. I'm talking about ordinary deductive logic, which even neuroscience scientists don't think has anything to do with how we think. And I'm just showing you that it does. Okay? Now one more thing. Yes, yes.
Where you're done with this.
Huh?
When you're finished, you start the question.
Yeah, okay. Have I gone on for an hour? I'm ready to start, I think. Yeah, okay, right. Okay, now I'm going to just read you something to sort of conclude. I think I've gone on long enough, and I got to main things I wanted to say. There was some other things I wanted to say about the hemispheres, which also, it turns out, have to do with memory. They don't have to do with those, different personalities that people thought that they gave you, or with one dominating the other. Basically, what the hemispheres do is the right hemisphere gets the gist. It thinks of all of the different possible interpretations or meanings of a word, and it holds on to them a long time. The left hemisphere chooses the word which is most likely, it forgets the others and goes on. But then, if it runs across a problem, if the meaning that it chose isn't the right one, if it doesn't fit, it calls on the right hemisphere to supply one of the meanings that it had come up with before. That's it. The left hemisphere processes the details, the right hemisphere gets the gist of it, and supplies new details when necessary. Now, it's more complicated, as everything is, but this is a big change from what was thought about the different hemispheres only a decade ago. Okay. Now, I'm going to give you one more illustration, if I may, about our logical thinking. There are many, let's see. Okay. Yeah, let's see where, okay. I'm driving around looking for a store since I happen to find myself in its vicinity. I know it's nearby because I've seen it before in that area, but I don't know exactly where, and I don't know its name, so I can't look it up. I come to a T-junction and stop. Which way do I turn? I look right. Residential, as far as I can see. I look left. Looks like a commercial sector a few blocks down the street. So I turn left. I can always come back or wander a little further if it's not there. There are many logical operations resulting in my decision to turn left, which can be modeled as syllogisms. Some of them, if arranged on deductive chains of reasoning, would be positioned fairly close to the final decision. Major premise: any street with only rows of houses, trees, and so on is residential. Minor premise: that street to the right has only rows of houses. Conclusion: that street is residential. Major premise: any street that also has parking areas and signs in view probably has stores. Minor premise: that street to the left has parking areas and signs. Conclusion: that street to the left probably has stores. Major premise: the store I'm looking for is in a part of its street that has stores. Minor premise: that street to the left probably has stores. Conclusion: the store I'm looking for may be in that street to the left. And on and on and on. We think all of these things unconsciously. Then what role does our conscious brain play? Whatever it is, nobody knows for sure. Here's the answer. The conscious brain picks up the conclusions of our unconscious logic, and only the conclusions. Our conscious brain works serially. We have an idea, then we have another idea, then we have another idea, and therefore people for centuries have concluded that we don't think logically. But they're only looking at our conscious thinking, which I think you'll agree after that is only a tiny bit of it. Yes, we have a big unconscious mind, but our unconscious mind is logical, and our conscious mind isn't. I hope that comes as a surprise. I hope I'm getting a bunch of -400 peaks in the room, because that's my climax, and that's all I have to say.
You get to stay here and answer questions. Who wants to be first?
Yeah. Oh, no, we mustn't turn it on. I'll turn it off. It'll burn out the lamp. Okay, hold on just a second while it's cooling. Any questions?
Yes. Mark, what's the question?
Now, can you repeat your last sentence? Okay, my last sentence was, that's all I'm going to say. Yes. Oh, the 400, yeah, okay, one before that, then I'll, all right, what I said was that our unconscious brains are logical, but that our conscious brains only pick up their conclusion. Therefore, the opposite of what we have been taught, that we consciously think logically, but our unconscious brains are, wild, sexy things. Because sex, by the way, works logically too. That is, it works syllogistically, but, I won't go into that. Anyway, what I said was that our unconscious brains are logical, but that our conscious brains are not. Our conscious brains are serious.
Years ago, I was asleep and started dreaming and woke up in the middle of the dream and thought, now can I be real quiet here and not let the dream thinking part of me know that I'm awake so it'll continue the dream, which it did. And then my fiancée was next to me asleep, and I thought, well, can I quietly speak to her and still not let the dream guy know that I'm awake? So I did, and she woke up, and she said, what is it? I said, I'm dreaming, and I would like to tell you about the dream. She said, wait a minute, and each of them got her dream journal that she always kept. And I narrated the dream to her, and the next morning I asked, did I talk to you last night about a dream? She says, actually, yes, I wrote them down, all three of them. I went back to sleep after the first dream, and whatever part that was continued narrating the other two. Now, which parts of the brain are all these things?
Okay, dreams are now thought, and of course what neuroscientists think. What neuroscientists think, they're going to be gone in a few weeks. I mean, they might be wrong. But what they now think is that our brains, while we are asleep, process the things that happen to us the day or the 3 days or the week before, in an attempt to make templates or to find a template for them to reside permanently, and so on. Okay. And dreams happen, doing that all through your sleep, not just in EEG, not just in REM sleep. But if you happen to, a portion of your conscious mind happens to wake up a little bit, while you're dreaming, then you'll see these things. And I think the fact that you often make sense of them just shows how much our unconscious mind needs to make sense of things. And so it was doing that. I happen to believe still that these are not just random things, that dreams do tell you some things about what you're thinking. And that if you can turn into a dream, that you'll learn things about yourself, how you really feel about things, and so on. We're embarrassed when we read the book when your parents had written the I'm glad to hear that. Oh, right. Well, we're still talking. Whatever part of it is that makes you talk and think, and so on, is partially awake.
Years ago, I had a friend who up east, or up north, Ohio, I think, was in a very bad automobile accident during the winter. He was in an emergency, and he lost all life signs for a period of time. Well, his memory of that was floating out of the hospital and going all around the area and exploring. And in doing that, he saw the body of a man who had drowned in the river, and they couldn't find him because he got swept down, up under the roots of a tree along the riverbank. And when he came back and his signs started indicating, well, his body came back to life. I mean, he was dead, according to the machines. Later, he told people about this, and the authorities went out there. They figured out where that was, and sure enough, there was the body, right where he saw it. What's that now? All of the EEG signals are gone at this point.
I recently read a book called let's see, Heaven Proved, or something like that. It was written by a neurosurgeon who had the same kind of experience, that is, he had died officially, and came back to awake after quite a long time, that is, in minutes, but, and said that he had seen heaven. He's a neurosurgeon, a scientist through and through, who thinks that heaven is approved, at least in his own mind. My take on these things is that he can't really prove that heaven exists without experience. But we, the people who deny it, can't prove that it doesn't. It's one of those things that, since we've never experienced anything like that, and it seems there was clear proof. I can't explain it. I don't know really that body would be there. But it never will be, because he had some sort of special spiritual insight. Yeah. He wasn't flying around or anything. I don't know. And no neuroscientists can explain that to you. Yeah.
I mentioned this in another week. I was reading an article years ago about a man who lived a normal life and went through school, got average grades, got married, had children, 2 cars in the garage. Very normal life. Then he had to have a brain x-ray taken, and all he had was a brain stem. He had no rest of the brain in his head. And apparently there have been several people found like this who seem to function normal. The machines don't work too well on that guy, I would imagine.
It's partly that, but actually that's a well-known phenomenon. He probably had more than just the brain stem. He probably had a lot of the limbic system as well. But you can actually do without your cortex. if you're born without a cortex, and this is most of the people most of the studies indicate that you can do without it. And you don't live you don't ever become any kind of leader in your community without a cortex, but you can get by, you can walk, you can remember where to walk, other little elements of your brain, or, who knows, take over those things, and you're not a total idiot, and so on. Yeah, that's been known for quite a while.
Yes. Hello. You mentioned that individuals that had severely damaged frontal cortex became vile and etc. Do you think this accounts for? Do you think that the damaged frontal cortex in some way accounts for the behavior of the sociopaths such as Hitler, Stalin, and Margaret Thatcher?
Yeah. Start off who? Yeah, I've read things about that, and I don't know what to think. I haven't drawn any conclusions, but the fact is that a lot of several people who are very successful, some of them very rich, have defective brains. Asperger's. They have Asperger's syndrome. Apparently aspects of your brain balance you, And if you're not terribly balanced, if, for example, you don't think at all of other people's needs, then that gives you a power to satisfy your own needs at the expense of everybody else, and you can get rich, and everybody else, pays the price. So I think there may be something to that. But once again, I'm not an expert at that. Those are things that nobody knows for sure.
Is there any evidence of that, in fact?
Yes. There have been books written about it which gather cases together that apparently do indicate that. Yeah.
Do you think we should therefore examine our potential leaders for the sort of defects in this respect?
I don't know. That's a tough one. You mean if they fail our tests, which happen to represent the science of the moment, they don't get to run for office? See, that's a hard one for me to answer. Yeah. Yes.
The thing that caught my interest was the function of memory is to recognize the present. But I thought to myself that there's a potential because you're superimposing, your memories, that you may confuse something brand new, with something you've seen before. It's called reductionism. So
absolutely.
Would you care to comment on that?
That happens all the time. People see something, put it into a category, and go on, and do not realize that it's new. Actually, I think some of the ideas that I actually state are new. Now, I may be wrong, but I state them to people occasionally, and they say, I see. So,
follow-up question. This business about recognizing the present to predict the future, my view would be is that has survival value and is fear generated. Would you agree with that?
I didn't hear that last bit.
It has survival value and it's fear generated.
Oh, yeah. Yes, I agree. Okay.
Yes, I have a question here.
Okay.
That was me? I don't know. I basically,
Okay.
yeah, well, are we good? Okay. My basic question is the conscious and the unconscious or the subconscious. I was in a horrible car accident when I was 18 years old. I was the only one that was left conscious. I was thrown out of the car, and when I came back to the car, I stepped over all the bodies looking for me. Not for anybody else. Was this my subconscious, my protective spirit or something?
I would guess so. You were in a state of shock, and your state of shock was preventing you from seeing what had happened all at once because you couldn't take it psychologically. But that's not neuroscientific. That's psychological, and I'm just guessing, But I think there is evidence that you do go into a state of shock, and so don't see everything, don't comprehend everything all at once, until you can manage it. Yeah. Wow. Okay, I'm looking forward to the answers. Oh, okay.
How would science deal with two things? One is out-of-body experiences, and another is the ability to do remote viewing, which is a developed science both in the United States and Russia.
The ability to promote what?
No, to do remote viewing, to see things at a distance or through time.
Oh, I see. Scientists deny it, deny both those things, and therefore you have to turn somewhere else. I mean, scientists don't have all the answers. Okay, thank you very much. I enjoyed it. Now you get to
Okay, now it's your turn to talk, so anybody that wants to get up here, got 5 minutes. Hank is first. Respond to what the speaker said, for or against. You have the floor, 5 minutes.
Thank you, Tom. That was very interesting. I felt I met a very logical mind that I understand. I feel like you were communicating very well with me. I did not register surprise when you asked that last question, when I understood it, because what I learned tonight about the subconscious, the unconscious mind being more logical than the conscious mind, made so much sense to me that by the time you got to the end, I was not surprised. And let me tell you why. It dovetails with my experience. And I will not disappoint you. I will talk about 911. Hey, okay. Last time I had to get a psychic cue from Susie before I said that. But I looked at some stuff. I got drawn into this because I met somebody that was there in the towers, and it just became more and more obvious the official story was really flawed. And it became also very obvious when I decided I better say something, when I learned enough to be able to say something about it, that there's a lot of psychological things going on with trying to convey this. For instance, like I'll talk to people here and say, well, will you look at my videos? And they say, yeah, and they never come back, you know. But anyway, in this kind of subculture, I'm one of millions actually that have decided that through logic we have to look into this further. Certain things have come up, and one of the words that you hear now is called cognitive dissonance, and that to me, this idea about templates is new to me, the template thing, but that to me really lines up with my experience in trying to deal with this, because I have experienced the thing of making people very uncomfortable because I'm bringing in cognitive dissonance. For those who care, cognitive dissonance is when you have an idea of the world that you operate off of. You find it very valuable to operate off of, and all of a sudden you find some information or some information comes to you that challenges this worldview, and that causes discomfort, and that's called cognitive dissonance. A typical reaction, depending on the person and many factors, is to kill the messenger, or whatever is the most quick and convenient way to get out of the discomfort. And anyway, this is something that you gave me kind of like a little deeper scientific idea of how that might work, because it's a definite phenomena. I mean, it's so obvious when you try to deal with this. The other thing that's also coming up more in my little world is the study of logic, because some of the evidence that we want to present is just like so obvious, and we are constantly confronted with the classical logical fallacies, and the crudest of them by the most powerful, sophisticated people. So we've become more, they didn't teach it to us in school, but now we know, the classical logical fallacies. So, Tom, is it 4.5 minutes yet? Okay, so you don't want to hear from me. We already had the Ph.D. here. The last thing I want to say is I'm an artist. I deal with illusion. I'm actually specializing in optical illusion now. So this is interesting, and I actually know a little bit about it.
Okay, who's next? Hal Holman. Five minutes.
Thank you for your presentation. I really enjoyed it quite a lot. One thing that I did years ago was to go take a week-long kind of group therapy course, which was good for analyzing the way that you think and react, and separating emotions from thought, not getting them all blended so one controls the other. And one thing that I was really reminded of was an exercise we did of taking an item in life that had been very difficult for you, with a lot of issues and a lot of emotions, and write it down, but write it one short phrase for each tiny bit of an item instead of putting 2 or 3 things in any one sentence. And then go all the way through those one by one and say to yourself, or ask yourself, do I know this aspect of it to be a fact from my own personal experience? And if not, you just draw a line through it. Then you go to the next one. You ask the same question, draw a line through it. You will draw, if you do it honestly, you will draw lines through probably 75 to 80% of everything you think you know about anything. It's just amazing. The emotions, you know, I've said here several times trying to drum it in. Any degree of emotion necessarily alters your perception of reality. And I agree with another thing you said, that often the very intelligent people get into positions of power and they're sociopathic. They have no feelings for other people. They couldn't care how much suffering bombs dropped all over children in Vietnam and in Libya and all these other places are. They have no feelings whatsoever. And that is why we have to actually take the time to analyze ourselves constantly when it comes to feelings, not to kill your feelings, but to logically to control them and not let them rule the color of your day and the color of the instance, because we can easily draw conclusions that are just not true. And never say, well, you did that because by golly your intentions were such. You may not, you don't know that. You speak from, this is the way I feel about that, now would you explain, am I right or wrong? And you'll save a lot of human relationships that way. But analyze it the simplest little piece at a time. Do I know this from personal experience as being a fact? You will find most of what you think you know, you don't know.
Okay, who's next? Who has been next? I can't believe this. Only 2 people going to talk tonight? There, Pat O'Connell.
I was actually going to do this offline with you, John. So I'm going to kind of let everybody into my dirty laundry here. And then maybe we can talk later. You might be able to give me some clues. But I have this affliction. And I believe it's associated, I think it's connected to an OCD kind of situation where, and we've probably all experienced it, you get songs stuck in your head. Well, I've had songs stuck in my head 24 hours a day for a solid year. So loud I couldn't hear my own thoughts. And so I started a blog, and I have now, I don't know, about 100 people who are following that blog who have found me who have this same thing. It's not musical hallucinations. It is the it's the recycling memory of a 10 to 15 second fragment of a song. It can also be a word. When I wrote my first women's health book, I knew that I was going to be going on book tours, and so there were these long chemical names that I was going to have to refer to, and so I would sound them out in my head. Never heard them with my ears, but those imagined sounds would get stuck in my head. And some of these people, I was able to get rid of them by getting my hormones squared away, but we believe the hypothesis seems to connect high levels of cortisol with this phenomenon. And obviously when you're having this, and some of these people have had it for 5, 6, 7, 10 years, I don't know how they've stayed sane. So we are all looking for answers, and maybe someone like you could help with that or something like that. But if anybody has thoughts or ideas about what this might be, how we might solve it, how we might solve it for other people, I can turn it on and off. Interestingly, I'm the only person among this group that can turn it on and off. I can turn it on by changing my hormone regimen. There's also a pair of identical twin boys. Their mom contacted me and said that one boy has this, the other boy doesn't. And I asked, what's different about the two boys? And she said, I said, you know, are there any stark differences? And she said, well, one of them gets thirsty a lot. I said, have you checked his blood sugar? Because high cortisol is connected to insulin resistance, and an insulin resistant condition is diabetes or that kind of thing. Sure enough, she took the little boy to the doctor, found out he had diabetes. So far we've got this little bit of a hypothesis that says cortisol is at the root of this, but there's also hormone connection. We have men and women both who have this. A woman contacted me about 3 weeks ago who is now in her, she said it started in her 6th month of pregnancy. So we've got all different conditions, but they all seem tied around hormones and cortisol, which is also a hormone. So I don't know what to do with this. If anybody has some answers, if you have some answers, I'd love to hear it. This is an experience that has to do with neuroscience, but I believe that there's also a connection to the chemicals. And interestingly, when I was 16 years old, I had this revelation that everything I am is chemistry. And if one were to change that chemistry, would I be a different person? And the answer is yes, because I've gone through that with menopause and then going back on hormones and playing with the combination. So it's a real kind of a curious situation to be in, to think that everything that I am could be changed just by changing the chemistry.
Okay, who's next? Have we got a next? There's got to be a next. Come on up. Well, come on up.
I just had a question for Dr. Walker.
We already covered that. We're on the...
Yeah, I know. Sorry, I missed the Q&A.
Come on up here.
Is it too late?
Come on up here. Come on up here.
You want me to go there?
Yeah.
Just for the question? Thank you very much. I had a question. I know you're eating, so you seem to be feeding your brain quite a bit right now. I actually had a question for you. You know, many of us have grown up understanding that we only use 20% of our brain potential. I'd like to know, number one, is that a fact? Do we know that to be the case? Or is it just that we say it on TV and places like that? And then if so, I'd like to know if we do have that extra potential that we're not yet using, would it be possible in the future, as we evolve as humans, to be able to use that potential to the point where we can cure our own illnesses? For example, cancer, or other illnesses that we might have, that we might be able to train ourselves to actually cure that. Is that a possibility? I know not in the near future, but certainly, do we have enough knowledge now about how the brain functions that we know that that's a possibility? Thank you.
Well, I heard two questions. One is that has to do with a very interesting point about do we use all our brains. One thing that was discovered by fMRI is that we use a whole lot more of our brain than we thought. You know, there's not a part of our brain that doesn't light up in response to something or other. our brains are so specialized that sometimes a part of our brain will appear to have gone to sleep, and then something will happen which brings it into play. The one thing that we haven't figured out yet, most of our brain, something like 90%, is white matter. That is, it's glion cells or glial cells instead of neurons, which is gray matter. For a long time, it was thought that that just holds the brain together. And some people who say we only use 10% of our brain or whatever were referring to that. They meant that the non-thinking part of our brains is just structural. However, now some scientists are arguing that we do use our white cells, the white portion of our brain, and therefore the question is open again. You know, nobody knows the answer to that. It's a very interesting question, but most people are taking a wait-and-see attitudes and find out if, after all, we use more of our white matter than we think we do, as well as our gray matter. Now, the other question had to do with, can we, by using more of our brain or by using it better, can we achieve some miracles or things that would have in the past been miracles? Certainly, advances have been made in training ourselves to control aspects of our body simply by thinking a certain way, ritualistically. We can lower our heart rate, we can lower our blood pressure. It takes, by doing those things, by training ourselves to do those things. And there's a lot of, the reason more people don't do it is that they're just too lazy. I am, you know, I never have trained myself to lower my blood pressure, though I could use it for sure. And also stories are told about people who practice yoga, and it's a kind of a brain training, who achieve all sorts of control over their bodies that the rest of us don't have. So I think there's something to it. What the limits are, I couldn't guess. You know, so.
Tom's not leaving till I get to the mic, I guess. Go away, Tom. Susan's stuck somewhere, so he has to go help out. Are there any more people that like to speak for the first time? No, I'm not blowing you off. Who did? Well, I'll tell you what, since he's not here and I'm in charge, you just come on right up here. Come on down.
I forgot something that may be the most relevant thing that talk triggered. This is a question for our speaker. It's also rhetorical for all of us because I'm pretty sure how this works. Getting back to that template and the logical, the subconscious mind being more logical than the conscious mind. Well, it seems like so much advertising and propaganda, which is really something I'm learning a lot about, and it's very prevalent, targets the subconscious mind. I think that's part of why people think they're very logical when they argue with you when they're not logical, because they're based on strong logic from their subconscious that's been programmed. So basically it's like this. Can artificial stimulus, this is maybe a more coherent question, AKA lies, illusions, misconceptions, etc., promote false logic in the subconscious mind? I mean, the answer is obvious, or else we'd be much more peaceful and advanced. But I'd like to put that in your frame of reference when you get your chance. Yeah, you can eat. I'll make up something else.
I'm not really hungry. They told me I had to eat, so I'm eating.
Before he gets his dessert.
Okay, when I talked about logic, I was talking about syllogistic logic. Syllogistic logic, whether or not syllogistic logic reaches a true conclusion as well as a logical conclusion, depends on whether your premises are true. For example, here is a logical syllogism. All blue pigs can fly. Giorgio is a blue pig, therefore Giorgio can fly. Now you may say that's totally illogical. And if you say that, it's because you're using logic, you're defining logic in a popular sense, which is the same thing as rational. You know, what you really mean is that isn't rational. Logic, the word logical is used popularly to mean rational these days. I was trying to go back to its original meaning as Aristotle used it.
I really want to focus on propaganda and how influential it is now. Not the dogma.
Go. I don't think there's any doubt but that propaganda and advertising can get through to you and can make you do what it's asking you to do. But that's only, I mean, people aren't that stupid. And so when when the propaganda is telling them something that they want to hear, then they'll let it in and they'll use it as argument to do what they want to do, or as an excuse, if you like. And they will come up with all sorts of arguments to their friends who they know might disapprove, which isn't their real logic. Their real logic is, their major premise is, I want to do this. Minor premise is, you know, this is being offered to me, so I'll do it, if you follow me. But I said that not only are ideas logical, emotions work logically, which is just that whatever and also I think needs work logically, whatever our major premises are, we apply them to the present situation every time. And our needs and our assumptions may just be cockeyed, but they still work logically, if you see what I mean.
You know what agape is?
Agape?
DARPA.
A dog?
DARPA.
Dogma, yeah.
Yeah, is that like really getting big in your field?
Dogma is a thought system, a logical system, which some group run religion or comes up with to originally or initially to clarify.
DARPA. Defense Advanced Research Projects.
Oh, I didn't know that.
Okay.
Okay. I think I did know that. Why? What's...
Well, apparently they're putting a lot of money into this end of things, trying to control people and read people's minds. I saw something last week where they were stimulating people's responses with magnets and stuff, making us into robots, and now it's going wireless.
I hope it doesn't work. Oh, it works?
Are there any more questions or talk? I'm sorry, Albert, you've exhausted my time. Oh, okay.
Years ago, I think I mentioned this here once before, I read a book called The 100th Monkey, and the subject was a group of scientists studying colonies of rhesus monkeys on islands off the coast of Japan. These islands formerly were part of the mainland, and storms washed out in between, so they became islands. Well, the monkeys had no predators. They had plenty of food, so they had the life of Riley. And the scientists then started putting out potatoes in the beach sand. And the monkeys found that they were food and liked them. And then they were just observing the monkeys' behavior. And one of the young monkeys took his potato over to the water and washed the sand off, and it tasted better. And he taught his parents, and he taught other monkeys, and slowly it propagated through the colony. But only the young monkeys would teach other monkeys. And then one day, every single monkey did it simultaneously that day. Not only that, it was a simultaneous occurrence on all of the islands that they were studying. The monkeys between those islands had no direct contact with each other, and it stunned these scientists. And they concluded from that this is evidence that at least in a species, on the subconscious level, we do not have individual minds. We're plugged into one mind. And I kind of think of thoughts like you're talking about all of the electrical activity they create in the brain. It's sort of like if a bird comes and lands on a limb, the whole limb's going to shake. And maybe the thoughts are creating the electrical activity rather than the other way around. Anyway.
Thank you, Albert. You just ruined my thinking. Monkey see, monkey do. Yeah, you blew it. Anybody else want to talk? Say anything? Do anything? Yes, here you go, young man.
I guess I'll say something that might sound a little bit controversial, but since that gentleman over there brought it up and about the whole idea of memory, I would add, if memory, I don't know if Dr. Walker mentioned this, but memory also is made up of what we learn, right? It's not just what we see. If we are taught in one way, then our logic is going to function based on that knowledge that we learned or acquired throughout our lifetimes. Let's remember that 600 years ago, leaders of this world were convinced that the world was flat and that the earth was the center of the universe. 100 years ago, well-respected doctors thought that smoking was good for you. So, we all base our decisions and our logic a lot based on those kinds of theories, whether they are acquired knowledge or taught. And so I wonder to what extent, part of the discussion of what the gentleman brought up, and when he mentioned lies, those were clearly lies, but we only know they were lies because we now know that the earth is not the center of the universe, and we know that smoking causes cancer.
We do have some people actually in this room that are flat earthers, and we are the center of the universe. Anybody else want to speak? Do anything? Dance, sing? Hank? No, we've had it from you, Albert.
I just had to say this. I think the issue you brought up of the doctors and smoking probably applied only to marijuana, right?
Medical marijuana only. So, keep your plants with fluorescent lights on them. It'll do it. I do. Anybody else? If not, John, would you like to, you have something, Doc?
Too much. My brain has been taxed too much.
We're going to have to get a brain tax on Doc here.
If you'd like to go up and kind of tie everything together.
Well,
And put over there and make it feel loud.
the only response I might have is to this gentleman.
I'll take it.
can take the other mic right here.
Is to this gentleman who was saying that we pick up information not just through our senses, although learning comes through the senses too, but I mean what we're told, but that's what most of the experiments are based on. Also, I think it's pretty well established, though I'm going along with popular conclusions, that we're born with a whole lot of templates. One of them, for example, means that we never see nothing. That is, when we look out there, even if we've never seen anything like it before, we'll see it. It'll be a substance or whatever. That seems to have been bred into, all animals, so that so we start out with something like that. But, and then we pick up information in whatever way we can, but it's all processed in pretty much the same way and so on. And that's why sensually based experiments continue to be used. It's kind of understood that they're not just talking about those particular kinds of things. The rest of it, of course, a lot of the things that everybody's commented on, like, for example, that we have oversouls, or, Jung himself said that we share a sort of common subconscious, and I believe almost everything Jung says, not really believe it, but I'm willing, certainly. I'm certainly not likely ever to say, Dr. Jung, I'm afraid you're just wrong. And I'm staying open to all these possibilities, but I've been open to most of them for most of my life. So if something doesn't happen pretty quickly, I guess I'll never know.
Well, that's it for tonight. We're get kicked out of here at 11 o'clock. If you want to stick around, you can. Our speaker is still here. You can talk to him if you want. But the formal meeting is over as far as that's concerned. Thank you.
This is William, your videographer from Two Hats Publishing. I hope you enjoyed this video. If you like it, please leave comments below, or like us, or follow us, and get notices to all our videos. Remember, when visiting the Mecca restaurant at the corner of Skillman Avenue and Live Oak, tell them you want your reservations to the next College of Complexes.